let's talk about the tiny, secret engines that run our entire world. I'm talking about microprocessors. Seriously, from the phone in your hand to the car you drive, there are these microscopic brains just making everything work. Have you ever really stopped to think about it? You click your mouse, tap a key, and boom, magic happens on the screen. But what is that magic? What's actually doing the heavy lifting, the thinking, inside all our gadgets?
Well, it turns out every single one of your digital devices has a brain, a tiny one, and that's exactly what we're going to crack open first. So let's meet the hero of our digital story. And here it is, the microprocessor. Now, the official definition is an integrated circuit that houses the whole central processing unit, or CPU. But forget the jargon. All you need to remember is this. It's the entire brain, the whole command center, squeezed onto one single tiny chip. Pretty amazing, right? But, even the smartest brain can't work in a vacuum. The microprocessor might be the star player, but it's got a whole supporting team. This team all lives together on what we call a motherboard, and it includes things like memory and other bits of hardware that help it talk to the rest of the device.
So what does this little brain actually do all day? Well, it's basically doing a constant three-step dance. First, it takes in data. That's you clicking the mouse. Second, it processes that data, figuring out what you want it to do. And third, it spits out a result. That's the thing you see on your screen. Input, process, output. That simple loop is running billions of times a second, powering your entire digital life.
Okay, now let's hop in a time machine for a second. We're going back to a single year that completely changed the game for technology. Yup, 1971. This was the year the very first commercially available microprocessor, the Intel 4004, was introduced to the world. You could say this was the spark, the granddaddy of every single chip in every phone, laptop, and smart fridge today. It all started right here. So we've come a long, long way from the 4004. Today's processors are unbelievably powerful. But how do we measure that? What actually makes one chip better or faster than another one? Well, it really boils down to three key things. There's clock speed, which is basically how fast it thinks. Then there's word length, which is how much stuff it can think about at once. And finally, it's instruction set, which is kind of like the language it speaks. Let's break those down. First up, clock speed. You've probably heard of this one. People talking about megahertz or gigahertz. The absolute best way to think about it is like a heartbeat. Every single beat or clock cycle gives the processor a chance to do something. So a faster heartbeat means it can get more stuff done every second. Simple as that. Next, we've got word length. This is all about how much information the processor can chew on in one go. We measured in bits. You've seen 8-bit, 16, 32, and now mostly 64-bit. Think of it like this. A bigger word length is like having a bigger mouth. You can take much bigger bites of data at a time, which makes everything way more efficient. And that idea of taking bigger bites is the perfect way to look at how these processors have evolved. I mean, the whole history of computing is really just a story of going from tiny bytes to huge ones, from 8-bit all the way up to 64. You can literally see the journey right here. We started way back with 8-bit processors, like the legendary Intel 8080. Then came the 16-bit era, which was a huge leap. After that, we got the 32-bit chips, like the Pentium, that really kicked off the home PC revolution. And today, we live in the 64-bit world with chips like Intel's Core series and AMD's Ryzen. Each of these steps was a game changer, allowing for more complex software and totally new possibilities. But hang on, it's not just about getting bigger and faster. It turns out there are fundamentally different ways to build a processor's brain. Different philosophies, you could say.
Yeah, this gets us to that third characteristic we mentioned, the instruction set. And in the world of chip design, there are two main schools of thought. On one side, you have CISC, and on the other, you have RISC. And they have completely different ideas about the best way for a processor to get things done.
So first, let's talk about CISC. That stands for Complex Instruction Set Computing. The whole goal here is to do as much as possible with a single command. It's like having one really complex instruction that can trigger a whole chain of smaller actions. This is the powerhouse philosophy you'll find inside most desktops, laptops, and servers. Think Intel's x86 chips. And then you've got the challenger, RISC, which stands for Reduced Instruction Set Computing. And its approach is the total opposite. Instead of a few complex commands, RISC uses a whole bunch of really simple, highly optimized, and super fast instructions. The name of the game here is speed and efficiency.
And this is the brain you'll find in your smartphone, your tablet, but also your microwave, your air conditioner. Almost any smart device is running on a RISC chip, usually from ARM. So there you have it. You've got the big, powerful CISC brains running our heavy-duty computers, and you've got the fast, efficient RISC brains running pretty much everything else. These two processor families, with their totally different approaches, are the hidden intelligence behind almost every piece of tech we use every single day. All of which leaves us with one final big question. We've gone from one chip back in 1971 to literally billions of them embedded in everything around us. They just keep getting smaller, smarter, and more powerful. So it makes you wonder, doesn't it? Where will we find the next digital brain? What's the next frontier for these amazing little machines?